Hey stats class, I'm going to go over how to find critical t-values using a spreadsheet. So what we got to remember here is that we are using the t-distribution. So I need t-inverse. I'm going to do equals t.inv. And the thing is, what we're trying to find is the number in the t-distribution, which remember has a 0 in the middle just like the z-distribution did. And the area, because it's a right tail, the area in the right tail is 0.05. So there's some number with 0.05 as the area to the right of it. And I'm looking for that number. But what we got to remember is this inverse procedure, just like it was for the z-distribution, that probability has to be the area to the left. And so if the area to the right is 0.95, the area to the left is, sorry, if the area to the right is 0.05, the area to the left is 0.95. So that's the first thing I need to put in here is the area to the left. And then the degrees of freedom, it tells me here the degrees of freedom is 10. So I just put 10 and hit enter. So there's my number, 1.81. It tells me 3 places, so I'm going to decrease that until I have only 3 decimal places. Alright, that's a positive number because it's to the right of 0. Alright, the area to the right is only 0.05, so that's a positive number. Alright, so there is my first one. Now, the second one, the critical value for a left tail test. So again, the mean is 0 for the t-distribution. And if I'm in the left tail, I'm below 0. So I'm going to be coming up with a negative number here. That 0.05 alpha in a left tail test is the area in the left tail. And I'm looking for a number, a t-value, that has 0.05 to the left of it. Right, the nice thing is that is exactly what t-inverse is. It's the area to the left. So I put the 0.05 in there. And then the sample size is 15. But the degrees of freedom is 1 less than that. So don't put 15 in there, I put 14 in. So degrees of freedom is 1 less than sample size. So now this time it's a negative, and be careful here. As you put a negative in there, don't put a negative in here too. Only put 1 negative in there. So negative 1.761. Or sorry, yeah, 1.761. So critical values in the left tail test are going to be negative numbers. Critical values in the right tail test are going to be positive. If it's a two-tail test, you're going to get 1 positive and 1 negative. That's that plus minus symbol there. All right, now what you got to be careful with here is in a two-tail test, whatever alpha is, right, there's 0. Alpha is 0.1. Well, half of that 0.1 goes to the left tail, half of it goes to the right tail. So these two tails each have half of 0.1, which is 0.05 in them. So you can find either one, it doesn't matter. This is probably the easier one to find just because it has an area to the left of it of 0.05. I don't need to do any manipulation to the inverse t process there. So that's going to be 0.05 and then my degrees of freedom. Alright, my degrees of freedom here is 13. My sample size is 14. So I need to back off 1 again. So 13. Alright, and then there's a negative right there, but I did plus minus out front so I can just drop the negative off. It's just a 1.771. So there's how we find the 3 different scenarios for critical t-values. Right tail tests are going to be positive, left tails negative. Two tails are plus and minus, but we got to remember, divide alpha in half for the two tail test.